Sure. Hello, everyone. Welcome to SCAM Live Solution. This is Shan from SCAM Marketing Team. As usual, we are happy to has this expertly and lightning fast live solution. Today, we are glad to have Arvind here. Arvind is our silver level coach and gold level teacher. Also, he is a very serious, heavy way in competitive programming. He makes the ICPC World Finalist and also ranked number 6 in the North American. We are thrilled to have Arvind here to our live. Let's hand over to Arvind now.
Right. Hey everyone. So I'll first talk about the bronze contest. There were 3 problems. I guess personally for me, I took the one last month and felt like this one was in general kind of easier, or at least like problems 1 and 3 were probably on the easier end. And then problem 2, I guess problem 2 is like it's kind of a brute force problem, and I'll talk about a bit more about it later. So let me first talk about general strategy when like opening a contest, right? So I have a copy of the problems here. So generally a good strategy is just to like read all the problems in the beginning. Since you never actually know like which one might be the easiest, maybe problem 1 will be the hardest one. And also like looking at the subtasks is generally like pretty useful, right? So in this one, like, you know that there's like one test for each different value of n. So in general, it's just pretty useful to look at all the problems in the beginning, and then just like make a plan for what problems you're actually going to do in the contest, right? But with that, I'll start talking about problem 1, right? So I think problem 1 was probably the easiest for many of you. So let me get my annotator. Right. So this problem, it's like you have a keyboard that has 2 letters, M and O. And then like every time you type in O, the letters get flipped, right? And then Bessie has like a favorite moo that's in the input. And then the question's asking if it's possible to find if it's possible to type the favorite moo, right? And then there's a lot of different subtasks for this problem. The key observation to make in this problem is that, so just like part of it is about reading the statement a bit carefully, right? And like actually understanding how this works, right? So, like if she types M, then if she types M, then basically the letter that's added at the end is M. And then if she types O, then the letter that's added at the end is O, and these get flipped, right? So what this tells us is given the input, like, you know that if she typed M last, then the last letter is gonna be M. And then if you know that she typed O last, then the last letter is gonna be O, right? So this actually gives you a lot of information about what's the sequence that Bessie actually typed, right? I guess let's look at the k=1 case where you actually have to construct the answer, right? So if the last letter that's printed out is O, then that means the last letter that's typed has to be O. And then these have to be flipped, right? And then if the last letter that was typed was, so if the word is like this, if the input is like OOM, then that means the last letter Bessie had to have typed had to be an M, right? And then it doesn't flip the later ones, right? So this leads to this kind of algorithm where you can kind of go from right to left because you know what's the rightmost letter that Bessie flipped. And then if it's an M, then you know that the next one has to be an O, right? And then if the string is moo, then you know the last letter that was typed has to be an O, and these get flipped, right? So this technically becomes OM, and then the last letter that has to be typed is M. And then this doesn't get flipped, it's just an O. So the last letter that gets typed is an O, right? Um, yeah. So that's like kind of the idea for this problem. And so this idea kind of leads to an O of n squared solution, which should be enough for like I guess there's like half of the subtask, or like more than half of the subtasks, like roughly half of the subtasks, right? So the algorithm is go from right to left. If you see an M, then just put M, or if you see an O, put O, and then flip everything to the left, right? And then the way to speed this up is you can just like keep a Boolean variable that tells you whether to flip the string, right? So yeah, so Boolean variable, it should tell you whether or not to flip. Yeah, whether or not to flip. To flip, right? And then you just go from right to left. Whenever you see an O, like in the flipped version, then you should flip this Boolean variable. And then whenever it's an M, you should just keep the Boolean variable as it is, right? And then based on this Boolean variable, the previous character before that is going to be either the flipped version or the not flipped version, depending on what this Boolean is. Yeah. Yeah, I'll just summarize the idea. Any questions? Yeah, so the key idea, which leads to which can lead to like a fairly quick solution, is that yeah, you know what the last character Bessie had to type was, and that motivates going from right to left to construct the sequence. Yeah, and then the answer is always going to be yes. Cool. Yeah, so that's how you do this problem. Yeah. Yeah, I think the next problem is probably a bit more interesting. But yeah. Yeah, any questions you can type in the chat.